We were talking about binomial distribution. The PMF of binomial is given by NCx p to the power of x and q or 1 minus p to the power of n minus x, with x taking values from 0, 1 to n, and p is probability of success in a Bernoulli trial, so it lies between 0 and 1. So we're talking about mean and variance of Bernoulli distribution. So we obtain E of x. So E of x is given by summation the x equals 0, 1 to n x into f of x. So usually we say the definition, which is for all values of x, total of x into its probability. So the all values of x for Bernoulli, so binomial cases, x equals 0, 1 to n. So have into x into the PMF, which is NCx p to the power of x into, let's say, q to the power of n minus x. So what we do here is we just simplify this by simplifying the combination NCx. And if you look into this case here, usually what happens is we'll be substituting x is equal to 0, x is equal to 1, and so on, x is equal to n, and we're simplifying that particular sum. So if I put x is equal to 0 here, I get 0 into NC0 p to the power of 0 q to the power of n minus 0, which is equal to 0. So when x is equal to 0, this term becomes 0 because you have x into n minus x. So the sum actually starts from x is equal to 1. So writing this from x equals 0 is same as writing this from x is equal to 1. So that's why, I just skipped a step in the previous class and I just wrote it directly so that x get cancels. When x get cancels, the sum starts from 1 at the head here. The reason behind that is because the sum is same whether you include 0 or not in this particular term. Now we can write x factorial as x into x minus 1 factorial, so that x could be easily cancelled, and I can write this n also as n into n minus 1 factorial. I can write n minus x factorial as n minus x minus x minus 1 factorial. Why we are expanding the sum like this is that to show that it becomes again a binomial distribution, but the parameters will be p and n minus 1. So I can cancel this x. I can take this n as well as p outside. So I'll be left with summation x equals 1 to n. I'll have n minus 1c x minus 1 p to the power of x minus 1 q to the power of n minus 1 minus x minus 1. So if you look into this and if you say that y is equal to x minus 1, then when x is equal to 1, my y will take 0, and when x is equal to n, y will be equal to n minus 1. So if we have y equals x minus 1, then as x equals 1 to n, y becomes 0 to n minus 1. So this sum now can be written as np into summation y equals 0 to n minus 1. So I have n minus 1 cy p to the power of y q to the power of n minus 1 minus y. So which is nothing but the binomial PMF of y variable with parameters n minus 1 into p. So since it is a PMF, that total will be equal to 1. So what you'll get is you'll get p plus q to the power of n minus 1, which is again equal to 1. So your mean simplifies to n into p. So these are the steps we should understand, and is not necessary to show in the derivation. So one can easily understand that. So what you just do is simplify this x factorial, try to cancel it. Now if we look into the same expansion of this x factorial, you can also write this x factorial as x into x minus 1 into x minus 2 factorial. So I can cancel out x and x minus 1, but not x square. So using the definition of e of x square, we cannot obtain expectation for this particular PMF. So we have to use a little trick there. So what we do is, since we have factorials, we are dealing with factorials, we can obtain the expectations for e of x minus 1, e of x into x minus 1, and such cases. So I can generate the moments like this, or I could have e of x into x minus 1 into x minus 2, because the factorial can be expanded like this. So these terms could cancel. By using this technique, we'll obtain the moments. Those are called as factorial moments. We'll deal that now. And using those, we could define our e of x square and e of x cube, e of x power 4, and so on. Now, simply I know that x into x minus 1 is nothing but x square minus x. So if I obtain expectation using this technique, that is x into x minus 1, that will be same as my e of x square minus e of x. But I need e of x square, but using the left hand side, I'll be getting e of x into x minus 1. So this implies e of x square, this e of x square. So when you send e of x to this side, it will be e of x into x minus 1 plus e of x. So to obtain e of x square for a binomial distribution, you have to obtain e of x into x minus 1 and add e of x to that. And we have already derived e of x. So we have e of x is equal to n into p. So now we'll see what happens to e of x into x minus 1. So I can call this as some equation 1, and we'll substitute this value and e of x to obtain e of x square. Now by definition, e of x into x minus 1 is summation over x, x into x minus 1 into p of x, which becomes summation x equals 0, 1 to n, x into x minus 1 into ncx p to the power of x q to the power of n minus x. Now again expand the factorials and cancel out x and x minus 1. So what we get here is summation x equals 0 to n. So I'll have x into x minus 1. Now ncx can be written as n factorial, n minus x factorial, and x factorial. Now I have to cancel x and x minus 1. So I'll expand this x factorial as x into x minus 1 into x minus 2 factorial. Now, since our x takes the value from 2, and if you observe, when you put x equals 0, you will get 0. When you put x is equal to 1, so you'll have 1 into 1 minus 1, which is 0. So simply this sum is nothing but x is equal to 2 to n, because when you put x equals 0, you will get 0. When you put x equals 1, you will get 0. So your sum is actually starting from x is equal to 2. And now since my x is taking value from 2, and if I want to convert this into the PMF of a binomial, I should take out n and n minus 1 outside. So I'll expand this n factorial also as n into n minus 1 into n minus 2 factorial. And this should be n minus 2 c x minus 2. So I'll just add and subtract 2 in this factorial n minus x, leading to n minus 2 and x minus 2 factorial. And since I have x minus 2 left, my p power should be x minus 2. So I'll split the power of p as p square into p power x minus 2, and q power x, n minus x, can be now easily written as q to the power of n minus 2 minus x minus 2. I'm just adding and subtracting 2 there. So when you simplify this, you'll get back your n minus x itself. So now we cancel out this x and x minus 1. So what I do, I take this n and n minus 1 outside, as well as this p square outside. So I get n into n minus 1 into p square, and I'm doing left with the terms x is equal to 2 to n, summation x is equal to 2 to n. So I have n minus 2 factorial. I can directly write n minus 2c x minus 2 p to the power of x minus 2 q to the power of n minus 2 minus x minus 2. So again, if you say that your y is equal to x minus 2, then for x is equal to 2 to n, your y takes values 0 to n minus 2. So this can be easily written as n into n minus 1 p square summation over y equals 0 to n minus 2. You will have n minus 2 n minus 2 cy p to the power of y q to the power of n minus 2 minus y. So which is nothing but the PMF of a binomial variable with variable value y and the parameters n minus 2 and p. So it will be left with n into n minus 1 p square into p plus q to the power of n minus 2, which becomes 1. So we have e of x into x minus 1 is equal to n into n minus 1. So this is the value of expectation of x into x minus 1 into p square. Now we'll substitute this in the equation 1 and simplify for e of x square. So can write this in the next line. Therefore, e of x square becomes e of x into x minus 1 plus e of x. So this has been derived as n into n minus 1 p square, and e of x we have already obtained that is n into p. So when you simplify this, we'll get n square p square minus np square plus n. So this is the expectation of x square for a binomial variable. Now once you have your e of x square, you can easily obtain the variance. So we have obtained e of x square. So variance of x is e of x square minus e of x whole square. So ಇಷ್ಟುವರೆಗೂ ಹೋಮ್ವರ್ಕ್ ಕೊಟ್ಟಿದ್ದೆ, ಮಾಡಿರೋರು ಸ್ಟೆಪ್ಸ್ ಚೆಕ್ ಮಾಡ್ಕೊಳ್ಳಿ, ಇಲ್ಲ ಅಂದ್ರೆ ಕಾಪಿ ಮಾಡಿ. So this is e of x square minus ex whole square. Ex whole square is np whole square, which is nothing but n square into p square. So that get cancels with the first term, and in the remaining terms, if you take np common, you'll get np into minus p plus 1. Now q is defined as 1 minus p. It is nothing but minus p plus 1. So this is equal to np q, or np into 1 minus p. That is the variance of the binomial distribution. Now if you look into the Bernoulli case, so we had Bernoulli mean is equal to, for the Bernoulli distribution, the mean was p and variance was pq, and we have defined binomial as n times of Bernoulli. So your binomial is nothing but sum of n IID Bernoulli. So you are adding n Bernoulli variables there. Each has mean p. So the final variable, which is your binomial variable, will have the mean n times p and variance n times of that. So when you, if you just see n times of mean of Bernoulli and n times of mean variance of Bernoulli, you'll get np and npq as the variance. Okay. So it's called e of x square derive ಮಾಡೋದು ಒಂದು ಲಾಜಿಕ್ ಇದೆ by using factorial moments. And usually the most frequent question from binomial is deriving the mean and variance, because it is very much hard or difficult in obtaining the next moment. So first moments it put that two moments mu1 dash and mu2 dash. Similarly, obtaining mu3 dash, mu4 dash are also based on the factorial moments, and computation of our central moments is much difficult here, but another number of steps ಜಾಸ್ತಿ. So usually ನಾವು ಅದನ್ನ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ ಕೇಳಲ್ಲ, ಅವಾಯ್ಡ್ ಮಾಡ್ತೀವಿ, ಬಟ್ ಹಂಗಂತ ಕೇಳದೆ ಇರಲ್ಲ ಅಂತ ಕಂಪ್ಲೀಟ್ ಆಗಿ ಡಿನೈ ಮಾಡಕ್ಕಾಗಲ್ಲ. Up to computation of beta 1 and gamma 1 ಕೇಳ್ಬೋದು. So we'll look into that. Before that, we'll look into some examples of binomial distribution and binomial variable, and then we'll proceed. Examples of binomials. We'll look into some numerical problems, and then we'll look into the derivation of moments. Binomial variable. So we have just defined it as sum of the Bernoulli variables. So if I say a single Bernoulli variable, that is number of heads obtained, a single coin is tossed. Now if you repeat that for n times, like n coins, say 3 coins, 5 coins, and so on, and if you look into the total number of heads, that becomes a binomial variable. So you can say what is a example of binomial variable. So it could be number of heads, or you could count number of tails also when, say, I'll take 4 coins are tossed. So if you assume that you have the fair coins, in that case, the value of p, probability of getting head, will be same as probability of getting tail. So p becomes 0.5. So my x is taking values 0 to 4. So n is equal to 4, p is equal to half. So assuming that the coin is fair, if it is unfair, you will have a particular value of p other than 0.5. Now similarly, you are visiting a family and we are counting, say, number of female children in the family of, say, 3 children. So you have selected the families which contains a total of 3 children. So one family ಅಲ್ಲಿ 3 ಜನ ಮಕ್ಕಳಿದ್ದಾರೆ. ಆ 3 children ಅಲ್ಲಿ ಎಷ್ಟು ಜನ females ಇದ್ದಾರೆ ಅದನ್ನ ಕೌಂಟ್ ಮಾಡ್ತಿರೋದು. So if you count how many females are there, you could get 0 or 1 or 2 or 3. So your n is equal to 3. Your x takes values 0, 1 to n, 0 to 3. Now defining p, so you can say p is probability that a child is female, or you could say proportion of females in that locality, because proportions in a large scale is also defined as probability by using the statistical definition. So can say p is the probability that a child is female in that locality, in that family, or proportion of females in that particular locality or city. And similarly, you can talk about, say, number of defective items produced. Number of defective items produced in a, say, batch of 20 items. So there is a manufacturing setup which produces 20 items in a batch. Out of this 20 items, you are counting how many defectives are there. So you could take the values. X could take the values 0, 1 to 20, and P is defined as probability that an item is defective. So you will be knowing these probabilities by the historical data. So you have observed the manufacturing process for a large time now. So you have the data, how many items are produced, how many items are defective. So if you take the proportion defective, that becomes the value of P. So this is how you can build your own examples. Now your examples are always such that you are fixing your n. So n first define ಮಾಡಬೇಕು. X value ಸಿಕ್ಕುತ್ತೆ, x ಏನ್ ತಗೊಳ್ತೀರಾ ಅದು ತಕ್ಕಂತೆ P ಇರಬೇಕು. So here you have counting the defective items. So success indicates defective here. I'm counting the female children. So success indicates female. I'm counting heads here. Then success indicates head. If you're counting tails, then success indicates tails. So whatever you have defined as success, the same success must be used to define the value of P, because P is always probability of success. So ಇಲ್ಲಿ ನಾನು x is equal to number of females ಅಂತ ಹೇಳ್ಬಿಟ್ಟು P ನ probability that the child is male ಅಂತ ತಗೊಳಕ್ಕಾಗಲ್ಲ. Then it is not defining the concept of binomial, because x is always defined as success, P is always defined as probability of success. Now, if you want to model the problem for number of male children, then define x as number of male children, and then you can take P as probability of males. Similarly, if you want the model for the non-defectives, then define x as number of non-defective items. Then you can define P as probability that item is non-defective. So it is all based on how you take success and failure. So again, requirement ಇದೆ ಅದನ್ನ ನೋಡ್ಕೊಂಡು ನೀವು ಸಕ್ಸಸ್ ಮತ್ತೆ ಫೇಲ್ಯೂರ್ ನ ಡಿಫೈನ್ ಮಾಡಬೇಕು. So some more examples when it comes to real life cases are, say, counting number of defective items. Then you could talk about number of arrows hitting the target. So you're counting how many arrows are hitting the target, say out of maybe 5 shots. So again, your x takes values 0, 1 to 5, and P is defined as probability of a successful hit. So all this could be obtained from the data, and you can have example of, say, number of people getting selected, number of people selected for a job, or number of persons selected for a job, say out of 6 who have given the interview, or out of 6 who are interviewed. Then if your x takes values 0 to 6, probability P is defined as the probability of selecting a person for the job. So P is probability of selecting the person. So this is how you could define the variable as well as the value of P for the binomial distribution. So it is always based on what is the total Bernoulli experiments you are conducting, and out of which what are the number of success. So each of these cases are Bernoulli. So one person giving the interview may be selected, may not be selected. For a single person, so it is Bernoulli. If you're looking into a total of 6 person, it becomes binomial. So examples ಕೇಳ್ತಿರ್ತಾರೆ, define binomial variable, binomial distribution with an example, and so on. So there are more examples ನೀವು ಕಲ್ತ್ಕೋಬೇಕು. So we'll look into some of the problems now, how the problems will be. So we know that the PMF is given by P of x is equal to x's ncx p to the power of x q to the power of n minus x. So a situation where a particular value of n will be given and the value of p will also be given. For various cases of x, you have to generate the probabilities. Now if you look into the general situation, my x is taking the value 0, 1, 2, 3, etc. So let me say some r, and then n, where r is an integer, n, then you can obtain the probabilities by substituting the values of x in the PMF. So you have P of x is equal to x, which is ncx p to the power of x q to the power of n minus x. So I'm deriving this generally for some values of x 0 to n. So when I put x and x is equal to 0, I get nc0 p to the power of 0 q to the power of n minus 0, which is nothing but q over n. So if you want the probability for 0, then it is simply q to the power of n. So if you know the value of q, then the probability that x is taking 0 is always q power n. So you can remember this. If not, ಈ simplified form ಗೊತ್ತಿಲ್ಲ ಅಂದ್ರೆ general form ಗೊತ್ತೈತೆ ಅಲ್ಲಿಗೆ x is equal to 0 ಹಾಕಿ simplify. So then when you put x is equal to 1, you get the probability as nc1 p to the power of 1 q to the power of n minus 1. nc1 is n. So I'll have n into p into q power n minus 1. And similarly, when you put n is equal to 2, you get the second probability, which is nc2 p square q to the power of n minus 2. So we'll not try to simplify this. So we'll keep it as it is, nc2, nc3. We can simplify ಮಾಡಿ ಬರಿಬಹುದು. So ಅದೇ ತರ if you want a particular value, say x is equal to r, then that probability is given by ncr p to the power of r q to the power of n minus r. And if you look into the case where x is taking actually n, so that will be ncn p to the power of n q to the power of n minus n, which could be simplified as p to the power of 1, because ncn is 1, q to the power of n minus n is also 1. So we'll be left with p power n. So here we are talking x is equal to n. X equals n indicates all n Bernoulli trials are success. All n Bernoulli trials are success. Each Bernoulli trial has a success probability of p. So when I say n such variable, it will be p into p into p to the n times, which is p to the power of n. Now similarly, if I say all failures, x is equal to 0 and probability of failure is q, when I say all my n trials have failed, probability will be q multiplied by itself n times. So it becomes q to the power of n. So in the questions now, a particular value of n and p will be given. So just substitute np for the required probabilities and you can estimate the probabilities. And sometimes you'll be asked with at least, at most, and so on. And we already know the values. At least k is nothing but x greater than or equal to k. At most k is nothing but x less than or equal to k. And then if I say probability of sum is, so m is sum is nothing but at least 1. Sum is nothing but at least 1. So you can use the formulas and derive the probabilities. Yeah, so we can take an example problem. Just give one problem. Okay. 5 students are selected to build a team for a particular competition. Full stop. The class has 20 boys out of total 30 students. What is the probability that the team will have first one, no boys. Second one, all boys. Third one, at most 2 boys. One, at least 3 girls. One, exactly 3 boys. Sixth one, exactly 2 girls. Also obtain mean number of boys and girls in the selection. So mean boys mean number of boys, mean number of boys and mean number of girls and the variance, standard deviation of number of boys. Question mark. 5 students are to be selected. 5 students are to be selected to build a team. The class has 20 boys out of total 30 students. 5 students are to be selected to build a team. The class has 20 boys out of 30 students. What is the probability that the team will have no boys, all boys, at most 2 boys, at least 3 girls, and so on? Okay, so first we have to bring the concept of the binomial here. So we'll try to build the problem based on the sub questions they have given. So most of the cases have boys here. So we'll define x as number of boys. So let x is equal to number of boys in the selection of 5 students. So 5 ಜನ ಸ್ಟೂಡೆಂಟ್ಸ್ ನ ಸೆಲೆಕ್ಟ್ ಮಾಡ್ತಿರ್ತೀವಿ. ಆ 5 ಜನದಲ್ಲಿ ಎಷ್ಟು ಜನ ಬಾಯ್ಸ್ ಇದ್ದಾರೆ ಅದನ್ನ ಕೌಂಟ್ ಮಾಡ್ತಿರೋದು. ಸೊ 5 ಸ್ಟೂಡೆಂಟ್ಸ್ ಸೆಲೆಕ್ಟ್ ಮಾಡಿದಾಗ ಅದರಲ್ಲಿ ನಂಬರ್ ಆಫ್ ಬಾಯ್ಸ್ 0 ಇರಬಹುದು ಅಥವಾ 1 2 3 4 all the 5. So these are the possibilities. So we have n is equal to 5. Now since I have defined x is equal to number of boys, I have to define p as probability of selecting a boy student, selecting a boy. Now as said, in a large sense, our probabilities could be just simply proportion. So it is just proportion of boys. Now the information given to us is there are total of 30 students in the class. Out of the 30 students, 20 are boys. So proportion of boys will be 20 by 30, which is 0.6667. So that is the value of P. So we have the value of n given to us. We have the value of P given to us. Now we can easily obtain the probabilities. So I'll show 1 or 2. You have to complete the remaining. On the first case, what is the probability of selecting no boys? So this no boys is also same as selecting all girls. So if you are modeling this for girls, then you will define x as number of girls in the selection of 5 students. Again, x takes the value 0 to 5, but p will be defined as proportion of girls. So it will be 10 by 30, which is 0.33. Okay, so no boys indicates all girls. So when since I have taken x as number of boys, the case which indicates no boys is x is equal to 0. So this is p of x, which is number of boys, is equal to 0. So before writing, we'll write the PMF here. P of x, a very big statement. So x follows binomial with n equals 5, p equals 0.6667. So PMF p of x is equal to x, ncx, p to the power of x, q to the power of n minus x, with x taking values 0 to 5 and p equals 0.6667. So the first probability, so if you know, it is simply equal to q to the power of n, because for every binomial, p of x equals q power n. So if you are not remembering that formula, you just use the PMF. So I'll substitute for this n is equal to 5. So I'll have ncx, which is 5c0, because my x is taking 0. Then p to the power of 0, q to the power of n minus 0, which is 5 minus 0. So it is just 0.3333 to the power of 5. So simplify that. That will fetch you the answer. H1 to the power of 5 is equal to 0.0041. So selecting no boys in that group for the team has the probability 0. So probability of observing 0 boys in the team or no boys in the team is equal to 0.004. And the second question says, what is the selection? So what's the probability of selecting all boys? So I'm selecting 5 students. So when I say all boys, so that implies it is P of X is equal to all boys. I then select multiply. So all boys in that X is equal to 5. And we know that for binomial, P of X is equal to N is just P power N. So directly P power N and ಬರಿಬಹುದು. ಅದು ಜ್ಞಾಪಕ ಎಲ್ಲ ನಿಮ್ಗೆ ಅಂತಂದ್ರೆ just use the PML. Hence the x, p to the power of x, q to the power of n minus x. So this just becomes 0.6667 to the power of 5. Which is 0.1317. So that is the second question. Now, third question is at most 2 boys. So we have definition at most k is nothing but p of x less than or equal to k. So ಏನಿದು at most ಅಂದ್ರೆ we are defining the bound for the maximum. So whatever may happen, we are not worried, but we are worried that the maximum should be k. Like say for example, bring at least k apples. Bring at least k apples ಅಂದ್ರೆ so if I say at least 5 apples, ನೀವು ಎಷ್ಟು apples ತಂದ್ರು ಸರಿ, but ಅದು 5 ಒಳಗಡೆ ಇರಬೇಕು. That is the